Alright, so in this video, we're going to be doing some practice with the test for divergence, okay? Now, all the test for divergence is really saying is that we're going to be taking a limit as n approaches infinity of our a sub n, which in this case is going to be 6 plus 5n plus 4n squared over 7 plus 2n plus n squared. Okay? Now, if this limit is not equal to 0, then we know that our series diverges. Okay? So, how do we do this limit? Well, we can either use L'Hopital, okay, we would have to use it twice, or what we could do is just divide everything by the highest power of n, which is going to be n squared, okay? So we can do that. We're at the limit as n approaches infinity of 6 over n squared plus 5 over n plus 4 over 7 over n squared plus 2 over n plus, that's just going to be 1. Okay? So you can see here that as the n approaches infinity, this is going to go away, this goes away, this goes away, this goes away, and our limit is equal to 4, which is not equal to 0. So we know that by the test for divergence, this series diverges. Okay, so we can write diverges. Now you may have to write a paragraph kind of justifying that, or you might have to write a couple sentences on that. That might be one of the things you have to do. But if it is, I mean, you just write exactly what I said. By the test for divergence, this series, and you can write out the series, diverges. Okay, you can say something just like that. All right, so that's going to do it for this problem. Alright, so we have our next problem up on the board here. We want to see if this series is converging or diverging, and that series is the sum from n equals 0 to infinity of 5n e to the n over n squared plus 1. Now to do this, we have to utilize L'Hopital. Okay, so we take the limit as n approaches infinity of 5n e to the n over n squared plus 1, and you can see that we're going to have to use L'Hopital. Okay, so if we use L'Hopital, we're taking the derivative of the top and the derivative of the bottom, and these are separate, so we're not doing any quotient rule or anything like that. Thank God. And after doing a L'Hopital, we get, well, this is going to be a little product rule. This will be 5n e to the n plus, well, it'll just be a 5 e to the n. That will be over this derivative, which is just going to be 2n. Now it may already be pretty clear of what's happening here, but we can make it a little bit clearer using L'Hopital one more time. So using L'Hopital again, take the limit as n approaches infinity of, well, this is just going to be another product rule. We'll get 5n e to the n plus, this will be 5 e to the n, and then we have that plus 5 e to the n from before, because the derivative of 5 e to the n is just 5 e to the n, okay? And we can divide, well, we'll divide by the derivative of 2n, which is just going to be 2. Okay? So, you can see that, well, this is obviously going to go to infinity, because we don't even have any n's on the bottom, and we have like e to the n, we have n, of course, it's going to go to infinity. So, since infinity does not equal 0, we know that this diverges. Alright, so that's basically it, okay? It's just taking a limit as n approaches infinity, and if it's not 0, well, then you know it diverges, okay? However, if it is 0, then you just have to move on to a different test, okay? That doesn't prove whether it's convergent or divergent. Okay, this is just a test for divergence. So all this can prove is if it's divergent. It will not prove convergence. So that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the test for divergence, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.